The following is an original production of AZPM News.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Today we'll talk with Lise-Marie Imbert-Gerard, Associate Professor of Mathematics at the U of A. Her area of research focus is in the math of wave propagation in plasmas. Lise-Marie will be one of the speakers in this week's College of Science public lecture series. Thanks for joining us today.
Thank you for having me.
So before we get into your current research, please tell us a bit about your background. You got your PhD in France. What drew you to the United States?
Yes, so when I finished my PhD, I was looking for new ideas and new ways of thinking. So I thought that going abroad would bring me some novelty in my ways of research and service to institutions in the community. So I was looking for international options, and I was very lucky to land a postdoc in a place where mathematicians were working closely with plasma physicists. So it was a wonderful opportunity for me.
Wonderful. We're very lucky. Your research involves really complex mathematical modeling to, for instance, understand how waves propagate in different media. What do you mean when you talk about wave propagation?
So there's many different types of waves that propagate and that we know about. So water waves is definitely one type of waves, but there's also seismic waves that are created. For instance, when there's an earthquake, there's also acoustic waves. Everything we hear is comes from an acoustic wave. Electromagnetic waves are used to propagate information between cell phones and satellites. So waves are really everywhere. And waves propagating in inhomogeneous media happen in all of these examples because the ocean has a different salinity in different places. The air has different properties depending on the altitude. And the earth is also an inhomogeneous medium because all the materials are different. So a plasma can be understood as a very high temperature gas in which the particularity is that electrons can detach from nuclei and they can actually move about independently of nuclei. So that is the specificity of a plasma. So a plasma is a gas with charged particles.
Tell us how you use that information, how you develop an understanding of these waves and why it's important to understand them.
There's essentially two parts to that. There's a part that is mathematical modeling, turning a physical problem into a mathematical question. And then there's a lot of interest in simulating what's happening because it's sometimes hard to build a model or to build the real thing. So you want to check it out first by simulations so that you can finally build somehow the optimal thing. And so performing these simulations in the most efficient way is something that is really important. And even though computational resources are growing at a very fast pace, being efficient at what you do is really important.
So how does that connect to plasma physics?
Plasma is described as the fourth state of matter. So there's solid, liquid, and gas, and plasma. Even though we are very familiar here on Earth with solid, liquid, and gas, in the universe, the most common state is plasma. So the stars are made of plasma, and in particular, the sun is made of a plasma. So how waves propagate in plasmas, they have to propagate through this inhomogeneous medium. And there's a lot of complicated phenomena that happen in this plasma. There's waves that cannot penetrate very deep into the plasma, so they're bouncing back towards where they came from. There's waves that can be transformed into other types of waves. All of these taking place in this inhomogeneity.
Give us an example of a plasma. Why is it that it's so important that you can understand how waves move through plasmas?
This is very relevant to the topic of my talk because I'm going to be talking about nuclear fusion on Earth and how can we reproduce these reactions that are happening in the sun in order to produce energy. We are designing reactors to produce energy with fusion energy. And within these reactors, waves are very important for a range of problems, going from heating the plasma to probing the plasma, because things are very hot, so you cannot go in and measure what's happening, but you can use waves sent from the outside so that they can capture some information about what is happening inside.
And how is this in the long range going to relate to sustainable energy production?
So it is important to address the global increasing demand in energy, and the current sources of energy that we have are not going to be able to catch up with the demand. So in order to supply, we need to investigate all possible kinds of energy, and fusion is one kind of energy that is very promising in this framework because it releases a lot of energy. And this is related to the fact that it works with things that are happening at the nuclear level of matter, where the forces that are at play there are very strong, and this is why these kind of reactions release a lot of energy.
The area you work in is pretty esoteric to most of us. Tell us what you want to get across to your audience in this College of Science lecture.
There's two main things that I want to get across. One of them is the importance of the numerical work that mathematicians do to help with simulations of physical problems, and the other one is related to mathematical modeling. I'm quite passionate about communicating about mathematical modeling. I have studied plasma models for a long time, and they're very technical, and I have spent quite a lot of efforts in communicating about these models, and not only individual models, but how they fit in together to advertise plasma physics problems to more mathematicians. And one of my goals is to bring more mathematicians to contribute to the very important problem of nuclear fusion.
Thanks very much for piquing our interest in your upcoming public lecture. It's going to be very exciting. Lise-Marie Imbert-Gerard is an associate professor in the University of Arizona's Department of Mathematics. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.
This has been an original production of AZPM News.